You know what's hilarious? When brilliant engineers spend millions of dollars creating climate control systems that end up being absolute disasters. And before we dive into these spectacular failures, hit that subscribe button because you're about to see some of the most expensive mistakes in temperature control history. Let's start with the walkie-talkie building in London, also known as the building that literally melted cars. This skyscraper had a genius design with a curved glass facade that was supposed to look futuristic and modern. Problem was, nobody did the math on how those curves would focus sunlight. The building became a massive magnifying glass, concentrating solar rays onto the street below. The reflected light was so intense, it reached temperatures of over 90 degrees Celsius. Jaguar cars got their panels warped. A doormat caught fire, and a journalist even fried an egg on the sidewalk. The fix? They had to install permanent sunshades, completely ruining the building's aesthetic and costing millions more. Then there's the Vegas Vidara Hotel, which had the exact same problem but somehow happened years after the London disaster. You'd think people would learn, right? This curved glass tower turned its pool deck into a death ray zone. Guests nicknamed it the Vidara Death Ray because it would singe their hair and melt plastic bags. One guest reported his head getting burned while swimming. The hotel tried to play it cool, calling it solar convergence, like that makes it better. They eventually had to add film to the windows and plant trees, which completely defeated the purpose of their expensive glass design. Moving on to the Sydney Opera House. An architectural marvel that's basically an oven inside. When they designed this iconic building in the 50s, they focused entirely on how it looked and completely ignored climate control. The result? The interior gets unbearably hot during performances. The air conditioning system they installed was so inadequate that performers would sweat through their costumes. They've tried upgrading it multiple times, spending tens of millions, but the building's unique shape makes proper air circulation nearly impossible. Concertgoers still complain about the heat, especially in the upper levels. Let's talk about Beijing's massive CCTV headquarters. This building looks like a twisted pretzel, and it's an absolute nightmare for temperature regulation. The irregular shape creates hot spots and cold spots throughout the structure. Some offices are freezing, while others are sweltering, often on the same floor. The climate control system has to work overtime just to attempt balance, resulting in energy costs that are through the roof. Employees literally bring space heaters and fans to work because the central system can't handle the building's bizarre geometry. Here's a good one. The Freiburg solar settlement in Germany was supposed to be a model of sustainable climate control. Every house had solar panels and was designed to be energy positive. Sounds perfect, right? Wrong. The homes were so airtight and well insulated that they trapped humidity like crazy. Residents started getting mold problems within the first year. The ventilation system was too weak to handle the moisture, and people had to constantly run dehumidifiers, which use so much electricity that the homes stopped being energy positive. The irony is painful. The Ryugyong Hotel in North Korea is a massive pyramid that's been under construction since the 80s. Among its many problems, the climate control system was designed for a completely different building layout than what was eventually built. When they changed the design multiple times, nobody updated the HVAC plans. The result is a system that would never properly heat or cool the massive structure. This is one reason among many that the hotel still isn't operational after decades. Disney's Contemporary Resort in Florida has a unique problem. The building was designed with a monorail running through the middle, which seemed cool until they realized it created a massive air circulation problem. The central atrium is either too hot or too cold, and the guest rooms on the monorail side get constant temperature fluctuations every time a train passes. The system has to compensate constantly, making it incredibly inefficient and uncomfortable for guests. The Tacoma Narrows Airport Terminal in Washington has a green roof covered in plants for insulation. Great idea in theory. In practice, the roof became so waterlogged during rainy season that it created humidity problems inside the building. The weight of the water also wasn't properly calculated, causing structural concerns. The climate control system couldn't handle the excess moisture, leading to condensation problems and uncomfortable conditions. They eventually had to redesign the drainage system at massive cost. But the Dongtan Eco-City in China was planned as a completely sustainable city with revolutionary climate control. They designed buildings to use natural ventilation and geothermal heating. The project failed spectacularly because the natural ventilation didn't account for China's air pollution. Opening windows meant letting in smog, defeating the entire purpose. The geothermal systems were installed in unsuitable soil conditions and never worked properly. The whole city project was eventually abandoned. Apple's spaceship campus in Cupertino has a philosophy about climate control that drives employees nuts. Steve Jobs insisted the building use natural ventilation instead of traditional air conditioning. Sounds eco-friendly until you realize Cupertino gets really hot in summer. Employees complained so much about being uncomfortable that Apple had to retrofit air conditioning into a building specifically designed not to have it. The cost of this retrofit was astronomical and completely unnecessary if they'd just installed AC from the start. The Bullitt Center in Seattle was designed to be the greenest commercial building in the world. It has composting toilets, rainwater collection, and a super advanced climate control system that uses geothermal wells. Problem is, the system is so complicated that it requires a full-time engineer just to manage it. When something breaks, which happens often, replacement parts have to be custom ordered at ridiculous prices. The operating costs are actually higher than a conventional building, defeating the whole purpose of being sustainable. The Torre de Cristal in Madrid is a glass skyscraper that becomes a greenhouse in summer. Despite having a modern climate control system, the glass exterior absorbs so much heat that the air conditioning can't keep up. Upper floors regularly hit uncomfortable temperatures, and the energy bill is insane. They've had to add reflective coatings to windows and upgrade the cooling system twice, each time spending millions more than budgeted. Masdar City in the United Arab Emirates was supposed to be a car-free, carbon-neutral city with innovative cooling. They built these wind towers based on traditional Arabic architecture to naturally cool buildings. Sounds great, except they're in the desert where temperatures hit 50 degrees Celsius. The wind towers just circulated hot air. Now they had to install conventional air conditioning in almost every building, completely abandoning their sustainable cooling concept. The Manitoba Hydro Place in Winnipeg was designed with a double facade system for climate control. Air flows between two layers of glass to regulate temperature. This works fine in moderate weather but fails miserably in Winnipeg's extreme cold winters. The system freezes up and ice forms between the glass layers, blocking the view and making the building look ridiculous. They have to use traditional heating anyway, making the expensive double facade system completely pointless. The Hearst Tower in New York has a beautiful diagrid structure that creates major climate control headaches. The triangular glass panels create uneven heat distribution throughout the building. And corner offices are either freezing or boiling depending on sun position. The HVAC system struggles to balance zones because of the irregular geometry. Employees constantly fight over thermostat settings, and some areas are just permanently uncomfortable. The Core building in Miami was built with a naturally ventilated design to reduce air conditioning costs. The architects forgot that Miami is incredibly humid. Natural ventilation just brought moisture inside, creating mold problems and making the building feel sticky and uncomfortable. They had to seal it up and install traditional climate control, wasting all the money spent on the ventilation design. Russia's Triumph Palace residential building has the most overcomplicated climate control system ever installed in a residence. Each apartment has individual controls that are supposed to integrate with a central system. The system is so complex that residents can't figure out how to use it. Most just turn it off and use space heaters and window units instead, making the entire expensive installation useless. The Council House 2 in Melbourne has a phase change material system in the ceiling that's supposed to absorb heat during the day and release it at night. Creative idea, but the material degraded faster than expected and stopped working properly after just a few years. Replacing it requires tearing apart ceilings throughout the building. They've mostly given up and rely on backup conventional systems instead. The Taipei 101 tower has a massive pendulum that helps stabilize the building during earthquakes. But it creates weird air pressure zones that mess with climate control. The HVAC system has to constantly adjust for pressure changes caused by the pendulum's movement. During high winds, the system basically gives up trying to maintain consistent temperatures, and people just deal with fluctuations. The Montreal Biosphere is a geodesic dome that was the U.S. pavilion at Expo 67. It's now a museum that's impossible to climate control. The dome design creates massive temperature variations between top and bottom. Hot air rises to the peak where it's basically wasted, while the bottom stays cold. They've tried countless ventilation strategies, but physics just won't cooperate with the dome shape. The Guangzhou Circle in China is a giant circular building with a hole in the middle. Cool looking, but the circular design creates a wind tunnel effect through the center hole. This makes climate control unpredictable because outside air constantly rushes through. Some offices get natural ventilation whether they want it or not, while others are completely stagnant. The system can't compensate for these random air currents. The Lotus Temple in Delhi has a flower petal design with no straight walls. Beautiful, but it creates impossible HVAC challenges. Air flows unpredictably around the curved surfaces, creating hot and cold pockets. The meditation hall is supposed to be peaceful, but people are constantly uncomfortable because temperature control is so inconsistent. They've upgraded the system 3 times with minimal improvement. The Seattle Central Library has a dramatic sloped glass exterior that looks amazing and performs terribly. The angled glass creates solar gain problems that change dramatically throughout the day. The climate control system is constantly playing catch-up. Some reading areas become unbearably bright and hot, while others are dim and cold. The energy costs are double what they projected. The Kingdom Center in Riyadh has a sky bridge at the top that's a climate control disaster. The bridge connects 2 towers and is enclosed in glass, creating an oven effect in the Saudi heat. The air conditioning struggles to cool this exposed glass tube. Visitors to the observation deck often complain about the heat, and the cooling costs for just that small section are absurd. Finally, the Burj Khalifa in Dubai, the world's tallest building, has a climate control system that has to fight physics itself. The temperature difference between the bottom and top floors is so extreme that the system needs different zones with completely different settings. Upper floors are exposed to intense sun and wind, while lower floors deal with ground-level heat. Condensation from the AC system produces thousands of gallons of water daily that has to be trucked away. The energy costs to cool this building are higher than some small towns use in total. It's a monument to excess that proves just because you can build something doesn't mean you should. So, what have we learned from all these spectacular failures? Well, the pattern is pretty obvious once you step back and look at everything together. Architects and engineers keep prioritizing how buildings look over how they actually function in the real world. They get seduced by innovative designs, cutting-edge materials, and the promise of sustainable solutions, but they forget about the basics. They forget that buildings need to maintain comfortable temperatures for the people inside them, and that sometimes the simplest solution is actually the best one. The really frustrating part is that we knew most of these lessons already. Climate control isn't some mysterious new science. We've understood thermodynamics for centuries. We know that curved glass focuses sunlight, that complex shapes make air circulation difficult, and that humidity in certain climates requires robust ventilation systems. Yet somehow, decade after decade, brilliant people with advanced degrees make the exact same mistakes over and over again. Think about it. London builds a curved glass tower without considering solar reflection. Vegas sees what happened in London and builds essentially the same building anyway. Apple insists on natural ventilation in a hot climate, despite having unlimited resources to install proper air conditioning. It's almost like there's a collective delusion in the architecture world where aesthetics and innovation override practical considerations and basic physics. The economic impact of these failures is genuinely staggering when you add it all up. We're talking about tens of billions of dollars spent on retrofits, repairs, and workarounds that should never have been necessary in the first place. That's money that could have gone toward actual problems, like building climate-controlled shelters for homeless people or improving ventilation in schools and hospitals. Instead, we're spending fortunes fixing vanity projects that architects refuse to properly design in the first place. And then there's the environmental cost, which is almost ironic. Many of these buildings were specifically designed to be sustainable and eco-friendly. The Freiburg solar settlement was supposed to be energy positive. Masdar City was supposed to be carbon neutral. The Bullitt Center was supposed to be the greenest building in the world. Instead, they ended up using more energy and resources than a standard building would have because their overly complicated systems require constant maintenance and constant energy input just to function at a basic level. The human element is often overlooked in these stories too. People work and live in these buildings every single day. They deal with fluctuating temperatures, mold problems, poor air quality, and constant discomfort. That's not just inconvenient, it actually affects their health and productivity. Studies consistently show that temperature control issues lead to higher stress levels, more sick days, and decreased work performance. So these architectural failures don't just waste money, they actually harm the people inside them. What's particularly interesting is how often the solution to these problems ends up being the traditional, boring, conventional approach. After spending millions on innovative designs and custom systems, these buildings eventually just get standard air conditioning installed. Now, it turns out that decades of development in HVAC technology actually created systems that work really well for most situations. Who would have thought that proven, tested solutions might be better than cutting-edge experimental approaches? Apparently not the architects designing these buildings. The ego factor can't be ignored either. There's something about building design that attracts people with strong opinions and even stronger egos. A famous architect designs something bold and innovative, and nobody wants to be the person who says, "Hey, this won't actually work in practice." Clients don't want to hire someone and then tell them their vision is flawed. Engineers' concerns get overruled by design vision. The result is that buildings get constructed exactly as envisioned, problems and all. There's also a disconnect between who designs buildings and who has to deal with the consequences. The architect gets their name on the building and moves on to the next project. The engineers who tried to warn about problems probably aren't around when things fail. The building owners deal with the cost of repairs, and the people living or working inside just suffer through discomfort while management decides whether to invest in fixing things. By the time anyone is really motivated to solve the problem, the original designers are long gone. We should probably be asking harder questions before construction even begins. What happens when this material is exposed to extreme temperatures? How will this shape affect air circulation? What's the humidity like in this climate, and how will our system handle it? Has something similar been done before, and did it work? These aren't revolutionary questions. They're basic, common-sense questions that should be standard in the design process. The really sad part is that fixing many of these problems isn't actually that difficult once you understand what's wrong. Putting sunshades on a building is simple. Installing proper ventilation is straightforward. Adding air conditioning to a building that was supposed to avoid it is literally just calling an HVAC contractor. The difficulty isn't in fixing things, it's in preventing the problems in the first place by doing proper planning and listening to people who actually understand how buildings work. There's also a generational knowledge loss happening here. When buildings like the Sydney Opera House were designed in the 1950s, my climate control technology was primitive. Some forgiveness is warranted. But when Vegas built the Vidara in the 2000s and made the exact same mistake that London made with the walkie-talkie, that's inexcusable. The information about what went wrong in London was publicly available. Someone just didn't care enough to look it up. Modern buildings have the advantage of computer modeling. We can simulate how air will flow through a space. We can predict how materials will perform under various temperature conditions. We can test designs before building them. Yet somehow we still end up with buildings that don't work properly. It's not a technology problem. It's a problem of people not using the tools available to them. So what would actually be revolutionary is if architects started designing buildings by first asking what temperature range the occupants need, what climate they're in, and how to achieve that efficiently and affordably. Then, after solving those fundamental problems, they could figure out what the building looks like. Aesthetic design. Second, not first. Functionality first, then innovation on top of a solid foundation. The buildings that actually work well are usually the boring ones that nobody writes articles about. A rectangular office building with standard windows, conventional HVAC, and no architectural ambitions maintains temperature perfectly well and doesn't break the bank. It's not exciting. You won't see it on the cover of architecture magazines. But it works, it's affordable, and people inside are comfortable. So maybe that's the real lesson here. Sometimes good design means restraint. It means accepting that not every building needs to be a statement. It means recognizing that form should follow function, not the other way around. It means listening to engineers and HVAC specialists instead of dismissing their concerns as unimaginative. It means prioritizing the comfort and well-being of the people who will actually use these buildings. We've created some genuinely beautiful architectural failures over the past few decades. They're impressive, they're iconic, and they're expensive object lessons in what happens when you let aesthetics override everything else. Every single one of these buildings would function better if some of the architectural boldness had been sacrificed for practical climate control. And that's something every future architect should keep in mind. Thanks so much for watching this exploration of architectural climate control disasters. If you enjoyed learning about these expensive mistakes, please hit that subscribe button so you don't miss our future deep dives into engineering failures, design disasters, and the fascinating stories behind them. We've got plenty more content coming that explores why brilliant people sometimes make not-so-brilliant decisions. Until next time, stay cool and keep your thermostat set to a comfortable temperature.